Water is one of the most valuable resources, and of all the planet's renewable resources, water holds a unique place as it is essential not only for sustaining all forms of life but also crucial for food production, economic development, and general well being of the population. Water scarcity is amongst the world's leading problems in the 21st century, and 54% of India faces high to extremely high water stress. Water scarcity has a multi dimensional impact: social, economic, well being, environmental, and sustainability. Growing population and industrialization of economies has led to more water use as well as in generation of wastewater. We all know what wastewater is. In simple words, it is that water which is used in people's houses or industries and therefore is not fit for reuse. But wastewater has its subcomponents as well: black water and grey water. Black water is the one which is generated from toilets and it contains harmful chemicals, and because of which it is not suitable for reuse. On the other hand, grey water is the one which is generated from activities like washing, laundering, etc. It is to be noted that grey water, if treated with required standards, can be reused for other purposes. Statistics suggest that grey water generated in India every year is around 1000 billion liters. However, unfortunately, 80% of it is discharged without treatment into water bodies and land. No estimates have been made of the sewage generated in rural India, but it can be safely assumed that none of it receives any form of proper treatment. Well, why is it so? It is because of prevalent limitations such as lack of space, infrastructure, technology, and unfavorable economic situation. A similar trend exists in most other developing countries, including China, where most of the peri-urban and rural population is not covered by any sewage treatment system. A major concern is that the existing sewage treatment technologies are not only expensive but require regular supervision by technical staff. These twin shortcomings make them unviable in the developing economies, except in a few situations. To solve the challenge of wastewater management, Abbasi, a professor and a scientist at the Pondicherry University, along with Dr. Tasneem Abbasi and team, developed a novel bioreactor called as SHEFROL, which is an effective, simple, and inexpensive method of sewage treatment. The acronym SHEFROL stands for Sheet Flow Root Level Bioreactor, in which short-sized terrestrial, aquatic, or amphibious plants are used in densely packed fashion in narrow channels, of which dimensions are optimized to ensure maximum effluent root contact and minimum short circuiting. A plug flow operation is approximated, which makes the reactor highly space efficient. Its feasibility in treating grey water has been established on the basis of extensive bench scale studies, followed by pilot plants and full scale plants. Guess what? All you need for SHEFROL to run is the sun, the gravity, and few commonly available plants as phytoremediators to treat grey water. How much does this cost? Well, mostly free and 70 times lesser than conventional grey water treatment systems on a per liter basis. Why SHEFROL? SHEFROL appears to be ideal for the decentralized treatment of sewage in schools, universities, residential areas, industries. The reactor is easy to set up, operate, and maintain. It doesn't use scaffolding of any kind nor any gravel, sand, stone layer to support the plants. And also, there is no need for any auxiliary aeration device or any external mixing for the reactor, thus reducing carbon footprint in the process. The SHEFROL bioreactor is inexpensive. A single unit sewage treatment plant to treat the waste from a few houses can be set up with just an amount of 30 to 35,000 Indian rupees approximately. It can be scaled up or down as per the demand necessities. SHEFROL's rate of treatment is as fast as conventional sewage treatment plants, making it highly efficient. It is easy to maintain since no machinery is involved, and with little training, even a layperson can maintain it. Therefore, SHEFROL bioreactor has a huge potential for job opportunities for disadvantaged groups and communities as well as for uneducated women. Conventional sewage treatment plants are mostly centralized and requires investment and personnel. But the SHEFROL bioreactor, because of its simplistic system, can overcome this impediment and make wastewater treatment effective and decentralized. SHEFROL has been shown to work with different species of not only aquatic and amphibious plants but also terrestrial plants. It is completely green, clean, and eco-friendly, uses no chemicals, and generates no pollution. SHEFROL has been successfully tested at Pondicherry University campus since 2006. The technology has been used to treat wastewater in Chinna Kalapet village near Pondicherry. It was seen time and again that the SHEFROL systems could be operated interminably without the need to invest in energy for pumping or recycling. Whatever plant debris was generated could be easily vermicomposted. All systems enabled not only near total secondary treatment but substantial tertiary treatment as well. These findings indicate the potential of SHEFROL as a clean, green, inexpensive, and an efficient option for large-scale treatment of sewage. Therefore, using SHEFROL bioreactor for wastewater treatment will help us in achieving Sustainable Development Goal 6 and in particular SDG 6.3, improve water quality, wastewater treatment and safe reuse. SDG 6.31, proportion of domestic and industrial wastewater flow safely treated. SDG 6.4, increase water use efficiency and ensure fresh water supplies. Water being essential for life, water crisis at the domestic and international level can profoundly impact national security. Hence, any effort in saving water is a move towards saving essential life resources and attaining self-sufficiency in water. Therefore, ensuring water security as an essential element for national security.